Dia has already introduced, but let me tell about myself. I am Dr. Tharun Kumar Reddy. I am currently working as assistant professor in the Department of Electronics and Communication Engineering at Indian Institute of Technology, Roorkee. So my basic area of work is AI and its application in healthcare, and I am mainly a signal processing person uh, and at heart AI scientist. So the first part of my talk briefly will give you an introduction to the various technologies and the different terminologies of Internet of Things. And in the subsequent part of the talk, we will learn about what is machine learning and how these two are related. Okay. So many of you know this term IoT, or even myself, I am very much familiar with this term from the last 10 years. Although this term is quite older than last 10 years. So what is Internet of Things? So I'll give you a very real world example. So recently we had an accident which has happened on probably Diwali night. So it happened in the Dehradun smart city. So what happened is two people were driving and supposedly drunk, and there was an accident, and they were badly injured and they have left their body. And now the problem comes later, that can they retrieve the video recordings of this accident in the smart city? So somehow it happened that somebody has hacked, and that that IoT node which is there in the smart city framework is not able to retrieve the video of the accident. This is a really real world example of IoT where somebody has to address. So the cyber security issue is really a threatening issue within the Internet of Things framework. Okay, so this problem actually one can work on. So many of our institutions, we have these webcams or different surveillance cameras. So all these nodes are open. So if you really want to work on them and bring in some security, I think we are the ones which we need that. Okay, so this is a very important problem of IoT, and IoT along with cyber security, and you have cyber physical systems. So this is a very booming area, and this example really mentions how much IoT is needed, and especially secure IoT, the need of secure IoT in the current time. So briefly speaking, IoT includes AI, IoT includes connectivity, IoT includes sensors, IoT includes active engagement, and IoT includes small devices. All right. So IoT is a combination of all these things. Okay. So how can you make a device smart? Okay. How can you make a device autonomous on itself? Okay. How can you make a device secure, autonomous, and smart? This is where IoT has played a very important part. So essentially, AI algorithms bring in some smartness within the device. That is true. Okay, for example, computer vision, or remote sensing, or whatever computer vision based algorithms, and connectivity, for instance. Okay, what is connectivity? So we have different protocols of connectivity, right, in the networking layer. So you have Wi-Fi, you have Bluetooth, you have different protocols, right? So IoT networking is an important part. Network is a very important part of IoT. And sensors, for instance, if you want to detect the person who's driving is met with accident, what you have to do? On the roadside, there are surveillance cameras, right? So they are actually sensors. They are computer vision sensors. Okay, so basically they are working in the sensor layer. Okay, and active engagement. So how these different layers, sensor layer, network layer, okay, how these are connected with each other, okay, for active engagement. So this is where is very important. And you have different devices also, like small devices, instance your mobile phones, your smart watches, your many of you must be having this Apple smartwatch or Tidbit. Many of you have Tidbit fitness tracker. So all these work on the principle of Internet of Things. So we will unravel all these mysteries in the upcoming discussion. So to speak very broadly, so essentially IoT is a framework. It is a networking of smart objects. Okay. See, so we have different smart objects which are networking with each other, and there is a constraint of limited bandwidth, limited power, and limited processing accessibility. Okay, all right. So these are different constraints these devices are operating in the real world, and for which we need a protocol, proper protocol of Internet of Things. So essentially, Internet of Things, a framework according to the 2020 conceptual framework, which was narrated in the research papers. So it's actually IoT is nothing but services along with data and networks and sensors. Okay. So what is this service? What is data? What is network? What is sensor? Okay. So we will understand this entire part right now. So essentially, IoT comprises a network of devices, okay, not only one device, but a network of devices that can actually sense, accumulate, and transmit or transfer, the accumulated data on the internet without any human intervention. Please remind this word or remember this word. It's very important. Okay. So IoT essentially is one step towards autonomy. All right. So IoT is also moving towards autonomy. So IoT is essentially a smart autonomous object networking. I could say it very simply in that phrase, smart object networking. All right. So Internet of Things, you have applications in different areas. For instance, in smart city, the example of Dehradun smart city I have given you. Smart home, suppose you want to, when you enter your home, you desire that light should be turned on. Immediately light will be turned on. When you want to go to bed, immediately you think that light should be turned off. So immediately bed light will be turned on, all other lights will be turned off. Okay. Suppose you want in the agriculture field that you want to uh, automatically provide fertilizer through drones. So immediately the drone should be operated and autonomously it should provide the needed organic manure or fertilizers spread on the crops. Okay. And similarly, healthcare facilities like remotely, for instance, in COVID, each of you must have seen in the COVID how our healthcare systems have been, there's a lot of stagnancy. I would say a lot of traffic in the healthcare system. The burden, I would say. So you can see how you could operate remotely and see how patients' parameters can be monitored through these IoT approaches.
Sir, one question to you, sir.
Yeah.
Uh,
Can I take questions towards the
so,
last? If
sir,
I,
this is basically context on this part. You are mentioning that IoT in healthcare systems. So, tele-ICU is a part of IoT healthcare system also.
which one? Which one? Can you repeat?
Tele-ICU. That the ICU is in telephonic mode or remote mode.
Yeah, yeah. So
So,
you are talking
so
about tele ICU.
tele-ICU is a part of IoT devices also considered, or it should be operated by the human beings only.
So, so essentially, we want to give as much autonomy as possible, right?
Sir, in ICU cases, is it possible as much as autonomy?
No, ICU will require, there is significant manual intervention from the doctors as well.
Yes, sir. But remotely monitoring the
But
ICU through
yeah, yeah,
telephony,
that is I understand. But sometimes, suppose in COVID wards,
that
right?
cases, yes, sir.
Yeah, yeah, that is not necessarily an ICU, right?
But
So
most of the cases, ICUs are not available for shifting the patients from the ICU, so they have to doing the things of tele ICU mode. So, do you think that IoT is an essential part of the tele ICU mode, or it is normally operated through without IoT devices?
well, I would say like partly IoT can be there in that. Not necessarily IoT is a complete part of it.
Thank you,
Okay.
sir. Thank you. Thank you, sir.
Better, I think we should look at some solutions based on tele ICU. Then we can comment on that,
Okay, sir. Okay.
right?
Okay. Thank you.
So essentially, I think IoT based telemedicine system we should have a more rigorous study on that. All right. Okay.
Okay,
Thank
sir.
you.
Thank you, sir.
So essentially, this is a brief history of IoT. So IoT essentially there is a lot of debate and I would say a lot of discussion which has happened, which moved I would say the flag from pre-internet era to Internet of Things era, right? So this is where it started. That we had pre-internet era where we had fixed and mobile telephony, SMS way of communication. And even before that, if I go back, people used to communicate through, PGNs or whatever, right? So I'm starting from pre-internet era. That is, the mobile phone came into picture, or landline, and then before that, okay, around that. So after that, you had internet of content, which is World Wide Web, right? So this is the next development. And you have internet of services. So people started using internet not only, but they have started doing consumer business, or e-productivity, e-commerce, etc. So it ignited the internet of services, which is web 2.0 protocol. And then we had internet of people. This is another phase of internet transformation. So people started using Skype, people started using Facebook, people started using YouTube, etc., and different social media platforms. And currently, where we are in this phase, which is, you have smart devices, smart objects, and smart data analytics. So this is, we have moved to a machine to machine communication here. Okay, so we have devices, uh, which are there, like a smart agriculture system where you have drones and a computer operator, or you have uh, a smart city with video cameras. So we all these follow this machine to machine communication, and essentially this is the transformation we are seeing right now. But originally, this term IoT was coined by a pioneer, Kevin Ashton, in 1999. So this is quite old technology, but it is getting transformed with AI and cyber physical systems. So, so what is IoT advantage? What is the advantage of IoTs, right? So let us see what is an advantage of IoT and what is the disadvantage of IoT before we go into these deep tech technologies. Let us try to understand what is advantage and disadvantage, right? So essentially, IoT will improve customer engagement. That is for sure, because there is a lot of opportunity to communicate. So it would obviously improve customer engagement. And secondly, a lot of data would be open, as I given you example of that IoT node in the smart city. So, and of course, there is a scope for reducing waste, because there's a lot of meaningful data which is coming up. So people will be knowing, for instance, the garbage bins are fitted with sensors, which can sense if the wastage is reached a threshold, right? And they will be tagged with RFID, tags, wherein the garbage people can understand, the track the wastage. So this would all provide an accurate picture of everything. But then there are some problems, as I told you, that the most important problem I told you is the hacker, right? So essentially, hacker basically would steal confidential information, right? As I told you in the Dehradun smart city. So the camera was tampered. Essentially, the somewhere the protocol was tampered by the hacker, and people don't are not able to access the video of accident. Okay, so this is a very important problem with IoT nodes. And essentially, cybersecurity is a very important aspect of IoT. That comes another research area, secure IoT, that is part of another discussion. And essentially, there are no international standards as of now for compatibility for IoT, because different devices come from different manufacturers, and how they communicate with each other, the protocol, it's very tough to define that protocol on a uniform way. And of course, there is a population explosion always. So the challenges are, enterprises are faced with real challenges to deal with this massive number of devices, massive number of traffic, which is put on the network. Okay, so all these problems are there with IoT, which we really need a lot of deliberation. So, so as I mentioned before, that IoT ecosystem would consist of web-enabled smart devices, embedded processors, sensors, and communication hardware. Okay, so all these are part of the IoT ecosystem. So IoT device, essentially they collect the data, share the data as necessary by connecting to a gateway, and/or another edge device. Edge device means on which computing happens, where before you send the data to the cloud, you do some processing. Okay, so so this is That is where edge device comes into picture. So these different devices communicate with other related devices and then act on the information. Okay, and all this happens once you set up this IoT system. All this happens without human intervention. This is where I was telling about no human intervention, minimal human intervention. So there are three types of interactions in IoT, as I told you. So one such interaction is device to device communication, right? So one example where this is useful is in home automation. So the moment you enter a home, right, as I told you, right, this is very much there in the top restaurants. You will see that when you go into that region, essentially lights will be turned on. And when you go out of the specific region of the hotel, you see the lights are turned off, right? So essentially, there is a communication which is happening between the devices, right? So there is a switch which is operating and it is connecting to the bulb, for example, or a tube light via a wireless protocol. Okay, so that wireless protocol can be Zigbee or Z-Wave or Bluetooth or whatever. So the different protocols are there. So all these can be part of a device to device communication. And then you have a device to cloud communication. Okay, so very important example is Samsung Smart TV. So I don't want to put any company here, but the smart TV, how it operates. Okay, so it basically sends information and enables a voice recognition system. All right. So you have device to device, you have device to cloud, and you have device to gateway communication. Okay. So essentially, a gateway is basically a device used between device and cloud. Okay, to basically facilitate the communication between cloud and smart device. Okay, and gateway is an intermediate, like it has different protocols like HTTP, TLS, or for example, you have IPv4, IPv6. Okay, to communicate with the cloud. So essentially, these are the gateways. So if I will give you an example of a gateway here. You have a fitness tracker. So the devices which have this fitness tracker, you see that they don't connect to the cloud directly. Now, how they connect is through a mobile app. Okay, so in this way, you can understand that a gateway here is a mobile app. Okay, so these are different layers of IoT. You have a sensing layer, as I told you, like a Fitbit smartwatch. You have a gateway here, right? Along with the network layer. So gateways are basically connecting sensors to the network layer. Okay, so gateway is that channel. And in the network layer, you have different protocols like Wi-Fi, Zigbee, or others, LoRa, or anything, etc. And then you have a processing unit here, like which has hardware and etc. Minimal hardware, which will do data processing. So this all entire thing comes under data processing layer. And finally, you are coming to the application layer where the data is, the results are shown. Okay, the user interface. So the device, the communication, connectivity, then the cloud, then the application interfaces. These are known as APIs. So the sensing layer. So we have, as I told you, we have four layers here. What are the four layers? So there is sensor layer, there is network layer, there is data processing layer, and application layer. So this is four layers which make up a IoT device. It auto IoT protocol essentially. So main purpose of sensing layer is to identify any phenomena in the, essentially I would say any anomaly in the device peripheral, and obtain real time data, right? Essentially, I'll give you examples of what I define here. So essentially, these are sensing layer has a small memory constrained or battery operated devices with onboard sensor and actuator. So essentially, this is a textbook definition, I would say. So we have different sensors and actuators on the device, so they all form part of this sensing layer. So on the sensing layer, you can sense and record data. You can perform also light computing, and you're also able to perform connection to a network and communicate the preliminary data, right? So very good examples you see here, like these motion sensors. So there are three broad categories in the IoT device sensors. A motion sensor, essentially it senses the motion, change in motion, as well as orientation of devices, right? So these very gyroscope sensor is very good example of that. Gyroscope data accelerometer sensor, right? So linear motion would the device linear motion and the device angular motion can be found out using motion sensor. A very good example is like you are in a home and you want to enhance the security of home. So you fit the sensors on the at the entrance or very windows or entrance to the home in the gate, or the different places in the garden. So essentially these sensors stand as guards to to deal with various situations, enhance the home security. So you see here the person is trying to do some theft, manage the window or do something restricted. So there you can actually use these sensors and identify what is happening there, if any suspicious activity is happening, right? And environmental sensors, these are second sensors. So these are basically light sensors. Okay, you could say optical sensors or sometimes even pressure sensors. So they essentially change or sense the change in environmental parameters. Okay, so a very good example I want to give here is like temperature sensor or humidity sensor or water pollution, air pollution sensors. Okay, so and even these are also part of home automation systems, and smart lights. So I just you can see here different applications, like you are in agriculture, you want to monitor water quality, right? Not necessarily agriculture, but the water purifiers, or you want to sample, you are a hydro engineer, you want to sample the water from different locations. So instead of doing a manual operation, you fit with different sensors in those tanks. So this would essentially give you any anomaly in the water level or water pollution. And monitoring soil, right? So essentially soil also you can monitor the moisture and the percentage of manure, percentage of nitrogen, phosphorus, etc., in the quality of the soil. So you can also monitor the moisture content, that will help you to prevent landslides. Okay, in fact there is a system from IIT Roorkee which is deployed in the Himalayas, so wherein landslide monitoring system using these different IoT sensors. And you can also monitor earthquake, tsunami, etc., using these different sensors fit in the different locations. Okay, and for air pollution monitoring also very useful, especially in the Delhi or different regions where you need to monitor the level of air quality in a very real time basis. And the third kind of sensors are position sensors. Okay, the position sensors basically they deal with the physical position and location of the device. For instance, some examples you can see here, like magnetic sensors and GPS sensors. Okay, so magnetic sensors, you have compass in your mobiles, right? Mobile phones, smartphones. So basically, it's a digital compass, and these magnetic sensors help you to basically help you fix the orientation of your display according to the direction. All right, and GPS sensor is also used. It's known as global positioning system, where with reference to a reference position, you can sense the distance traveled by the body from that reference position. Okay, so this can help you to detect if an object is present or absent as well. So these three sensors are part of sensing layer. Okay, then comes the network layer. Okay, so what is a network layer? Essentially it will transfer the data which is collected in the sensor layer to other connected device. Okay, so this is where a network layer comes into picture, right? So network layer in IoT devices uses different communication protocols like Wi-Fi, Bluetooth, Z-Wave, Zigbee, LoRa, and cellular network, etc. So essentially, it will serve as a medium or channel to allow data flow between different devices within same network. Okay, and the subsequent layer is your data processing layer. So what does data processing layer do? It has a data processing unit. You have a subunit within the IoT device. So what it does is essentially it collects the data in the sensing layer, and it tries to make any preliminary decisions rather than making it on the cloud. Okay, so like for example, you have smartwatch, smart home hub, etc. So essentially it will help you, give you a better experience. Okay, so how you can improve the experience of that technology. So and then it can process that data and give it to another device through the network layer. Okay, so these are data processing layers, network layer, and sensing layer. And let's comes the application layer. So application layer, you can think of an interface. Okay, it's basically a user centric layer which will execute various tasks. So most of the processing is now over, it has to show the result to the user. This is where comes the implementation of application layer. Okay, so for example, you have a smart display or a smart monitor, etc. All this part of application layer. Now many times people ask this question, that what are the different IoT tools I can use for enterprise, or I can use for my open source studies. Okay, so I would just give you a brief idea of the current platforms, different IoT platforms which are useful if you want to really play with for your applications. So these can be useful for smart home, smart city, home automation, and healthcare or automation, automotive. Okay, so one such platform is KAA. Okay, so it's known as K server. So this is K, which essentially this is a IoT platform or a IoT framework. So they are enterprise. They provide enterprise IoT framework to different clients. So essentially, they'll help you set up the entire device framework, setting network layer, everything from scratch. Okay. They also provide free training essentially, and they have certain trial versions as well. So it's very worth to try this KA approach. This is one of the very first one, which is very important. Then you have this different one like siteware. So siteware is essentially maybe if some of you are from software developers, if any of you, you might be very familiar with these terms here. So essentially, siteware is again an enterprise IoT framework. So it can integrate with third-party frameworks. It can work with database storage. It can work with visualization of data. So different frameworks are there which can work with siteware open source framework. And there is ThinkSpeak. Okay, so it will collect data in private channels and share with public channels. So it has very different features. It can work with MATLAB. I'm sure it will work with Python as well, and it will give you a visualization. Okay, and it is also having a facility to integrate with different apps. And this is another one, device hive. Basically, when Alexa was has come up, around 2020 or 19, I'm not really sure. The Alexa was coming by sent by put in by Amazon. So wherein this device hive has started to play a very important role. So it can collect directly integrate with Alexa, and it can support any device, and it also propose or supports big data solutions like Apache or Kafka, for real time processing. Okay, so basically this is on top of machine learning on your device data. So all these IoT layers, different layers, are on top of your machine learning layer. Okay, and this also supports Android and iOS libraries. And you have this Zeta platform, which is basically it will help you to support a different range of hacker boards. For example, you're working with IoT. Very important problem is the nodes are open. So Zeta board will help you to deal with these issues. And also Things board is another such platform. So I would recommend that you go through these basic IoT frameworks if you want to really have a hands-on with it. So I would like to illustrate some examples or applications of IoT. So some of you might be working on this in your college or have these agriculture platforms, right? So essentially, if you see that basically ours is an agrarian society, and it's very important that we uh, put our maximum efficiency. We need a maximum efficiency in the agrarian section of society, because people can live without any other thing but not without food. So it's very important that we have a very smart and sustainable agriculture framework. So an IoT, I'm sure, will play a very prominent role in that, because IoT can help you monitor quality of soil, not tiring the farmers, and will help you to regulate water supply, will help you to monitor the weather and accordingly, cover your crops. So I've recently been to a private university in the state of Andhra Pradesh. So they have this smart protection system for farming. So wherein they can sense the external weather and accordingly they can provide a protection to the crops. Okay. So it's like smart soldier in agriculture. So all these could be possible only by IoT. All right. And many times animals get sick. So it's very difficult sometimes for even human to operate in those settings, except for sometimes, right? So in those settings, these sensors can help you identify the animal with ill health and separate it or provide it approximate isolation. All right. So this is a smart agriculture system I was telling about. So basically, this is a farmer is operating it, but this is a technical farmer who can use Wi-Fi and computer control with agricultural drones. So this is a greenhouse IoT setup wherein with optical sensors, or you can provide the plants the necessary sunlight or the proper lighting facility to create chlorophyll. All right. So, and customer usage, you have these private citizens using wearables or smartphones, smartwatches, so they can monitor the health in remote situations. All right. Many times, the first participant asked this question, what is the role of IoT in healthcare? Tele ICU example he has given me. So essentially, many times, villages, suppose sometimes, delivery has to happen, or suppose in Uttarakhand state, we have different universities, medical universities in the Dehradun city. So they want to monitor in the hilly regions what is happening to that pregnant lady who is going to deliver a baby in which some of the XYZ months. So essentially, IoT is going to play a very important role, remotely monitor the health parameters, okay, and give a real-time feedback. And also security is very important. Like I gave you example of a threat or perpetrator entering the house. So security is very important. So you have a smart lock which will provide further enhanced security once it senses that a perpetrator is coming close to the house. All right. So likewise, IoT is going to play a very important role, like smart beds, for example, and also sensors to identify if a patient has fallen or suffering from heart attack. Like many times you don't see the person. You may be going to office, you may be going somewhere, but the person is at home and you don't know what happened. Sometimes the person might have fallen, the person might have injured, person might have got a stroke. You don't know what is happening. So it's very important that we monitor remotely through this different technologies. So nowadays, insurance companies are also using IoT wearables. Not in India yet, but abroad you have these Fitbit wearables where policy holders are offered discounts for IoT variables. And manufacturing, you have RFID and GPS sensors, and all these different places, IoT is going to play a major role, right? So remote control applications like switching on and off appliances to avoid accidents. Like suppose you are driving a vehicle and remotely somebody is monitoring you, right? So basically, if you are drunk or you are asleep, the device can itself take control and turn your vehicle or put into a safe mode, okay, like autopilot. So this is all possible because of IoT. And refrigerators, like many times you don't know refrigerators are smart. Sometimes we want smart refrigerators wherein it can identify sometimes a fruit or vegetable is rotten. It needs some special care. It can display on the give an alarm to the user or show it on the display. This is all self-intelligent or IoT-based systems with smart home applications. Okay, and you have kitchen also. You have sometimes there is a leakage of cylinder gas, right? And there is a fire. You have fire alarm, but otherwise sometimes leakage goes unnoticed. So you need to have a framework or a smartphone app which can remotely do these things. Okay, you may not be at home, but sometimes the home may be at fire. These are different cases in which IoT can remotely help you. Okay, so this is a intelligent and weather adaptive lighting system in street lights. You can see that you can many of you might have seen it in star hotels and restaurants already, but this is there in the West. So according to weather, and you have these adaptive lighting in street lights. So also there is smart parking, like you see here. Essentially, uh, areas are disclosed. Very tight bounds are there where you can park your vehicle. So essentially, there is a very strict bound monitor parking space in real time. So you have ground sensors, you have infrastructure sensors to be able to identify and reserve the available spaces. So this is part of smart city. For instance, you can see smart parking. Okay, digital video monitoring, fire control management, public announcement. In the time of war or something, you need a public announcement system. You have a transportation system, intelligent highways. There is a driver who's a thief. Actually, recently we saw a thief with ambulance who is creating issues on the highway. There's a big message on that. This situation can be addressed using this smart transportation or smart IoT approaches, right? And this is a final, last but not least, final application where you have waste management, right? So it's very important that somehow we detect the rubbish in the containers. Many times humans are not so empowered or equipped to be protected from these waste management, essentially to optimize the trash collection routes or sense the garbage level of garbage levels in the with RFID tags, and also recycle the bins. So all these different things can help the sanitation staff to essentially monitor the garbage and when to put out the garbage. Okay, so essentially a monitoring staff need not come every day, but he can sense through IoT that when he has to come and pick up the garbage. Okay, so this is a I've taken this from a website. This is IoT based approach. So this is where the IoT and AI are coming up. Okay, where signal processing and machine learning can come up. And finally, you have a digital twin. Okay, this is another very interesting area which has emerged from AI, IoT, and ML. Right. All right. So this is a brief, I would say, a brief bird's eye view of IoT. Essentially, we started from different layers, different type of communication protocols, and different types of IoT, and we saw different applications for sensors and different real world applications. And now we are moving to this is a entire bird's eye view. You have end this entire slide will end that. Okay, you acquire the data, gateway layer, analyze, disseminate to the cloud AI models, store and data mine, and give it back. So this is the entire life cycle of a IoT system. So there is an edge device you see here, the edge. This is the cloud, and this is the backend. Okay, so this is the complete data life cycle with AI, and this is without AI and at the edge essentially here. Okay, so the edge device itself does without AI, and cloud essentially has AI here. This is a difference between this and this. Okay, so my next part of the talk will brief you a brief idea of the life cycle of machine learning models. So essentially, machine learning, where it stands and what is the current state of the art, and how you can connect the dots. That I would leave it at the end for us to contemplate on. So AI, as you all know, is a buzz term which is coming up these days, and very much famous. So essentially, AI includes machine learning, deep learning, and hardware and software essentially. So combined with AI, IoT, most majority of the IoT part falls in the AI. Okay, so basic the architecture of AI is like this. So again, essentially you have sensors, right? All these are there within this, but there is some difference between IoT and AI. Essentially, AI can be embedded with IoT. Okay, so AI essentially is that the machine that which makes machines think that they have intelligence. This is a very wonderful definition given by John McCarthy. Okay, but as of now, we are very far from intelligent machines to speak. I would say so. We are able to do natural language processing. We are able to do computer vision. We are able to do automatic speech recognition. Okay, but that is not yet sufficient to make an AI. So essentially, machine learning is a subpart of AI. So machine learning will comprise of four different types of learning methods. Okay, supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Okay, so these are four different types of machine learning approaches. All right. So out of these, only supervised learning has works with data with labels. Okay, and all other forms of learning, semi-supervised also has partially labeled data, but reinforcement learning and unsupervised learning, you need not have a target variable with labels. Okay, so it's a very good important subset of machine learning we are going to focus today, because nowadays people do machine learning means it only means deep learning. Okay, so deep learning is a very important subset of machine learning. So which is essentially a multi-layered networks which work to learn from vast amount of data. Okay, so for example, you see here you have this kitchen room, right? You have extract the low level features, mid level features, high level features, and finally you classify or obtain the complete picture of this image and its class. Okay, this is outdoor image or indoor image, etc. Okay, so this is the entire structure, right? So essentially, what is this deep learning is that it will automatically learn the features. Okay, this is a very important. I would say the essence of deep learning is an automated framework. Okay, so it's an automated version of machine learning. So you don't need to build any rules from scratch. The method itself learns its own rules. You don't have to predefine any rules. So this is the brief history of deep machine learning. So essentially, everything started with McCulloch and Pitts in 1940. They were working on electronic brain, and they built a neural network with neurons, right? And finally, we are here. I would say we are not yet here. We are far ahead of this. In 2025, this is Jeffrey Hinton, who got Nobel Prize in physics because of his contribution to deep learning models based on physics. So this is a brief history of deep learning. I would not focus much on this, but I want to shed some light on a very important thing here. So essentially, what McCulloch and Pitt did in 1940 is they built this neuron model. Okay, so just after McCulloch and Pitt, it would actually Rosenblatt who has built this neuron model. Okay, this is known as a linear neuron. Okay, so what is a linear neuron? It will take the inputs, calculate the weights, multiply the weights with inputs, add bias, and pass it through a threshold function. So if the value is greater than 0, I would say it is 1, otherwise minus 1. Okay, so this is like saying that the image is an indoor image or outdoor image. Okay, so you can do it using this threshold unit or linear neuron. Okay, these are also known as perceptrons. Okay, so perceptrons are linear neurons. So then comes a multi-layer network. Okay, so perceptron was built in 1957. It's a linear neural network. All right. So then Jeffrey Hinton, he in 1985, he built this multi-layer networks. Okay. So they are non-linear networks. These are not linear networks. So this is Jeffrey Hinton who got the Nobel Prize, the same person. So he constructed this second generation neural networks in this manner with output layer, hidden layer, and input layer, along with an active. This is known as an activation function. You can see. I will show what is activation function. This is the cost function. All right. So they can update these weights and learn this neural network. Okay, this is second generation neural network. The first generation neural network is your perceptron model. So essentially, a multi-layer network, the second generation neural network, can make this kind of decision surface. Okay, but a perceptron cannot make this kind of decision surface. All right, this is known as a non-linear decision surface. Okay, so here you see that this is known as an AND problem. So you must be familiar with AND gate, right? So in the digital circuits, AND gate, what it does, when both the inputs are high, it would give an output of high. When any of the input is low, it would give an output of low, right? So this kind of function is basically the AND function. So you can learn the AND function basically using a linear network because you can draw a line and separate these data points, right? But consider XOR. Okay, so you consider XOR, you cannot do this kind of operation, right? So if you consider XOR function, what it does, it is basically exclusive OR. What is exclusive OR? Basically OR and plus NOT gate, right? So OR means this would be 1, but NOT of this will be minus 1. This will be minus 1. NOT of this is 1, right? Like that you have a XOR means NOT plus OR gate. Okay. So this you cannot separate these data points using a linear line, right? You need a curve, non-linear curve. Okay, so therefore XOR cannot be solved using a perceptron model. Okay, so this is known as a linear separable problem, which needs a non-linear layer, which is known as multi-layer network, which is again built by Jeffrey Hinton. Okay, this needs a non-linear activation function. You can see that you need a non-linear activation function, right? So there are different nonlinear activation functions you can see here. So one such function is rectified linear unit, which is very much in use nowadays, right? So tan h and rectified linear unit, these are two different functions which are very much useful for deep learning. All right. So this is your rectified linear function. So a combination of these different layers will make a deep network, which is part of AI or deep learning. Okay, so your brain also has such different layers, so which is the major motivation to build these computational networks. So basic breakthrough happened in 2006 when these three different AI researchers collaborated to or worked independently and came out with this deep learning approaches. Okay, so these are like the static networks, or these are like linear net. I would say a feed forward network. Okay, and then people have come up with another idea which is known as a convolutional network. So what convolutional network does is it uses convolutions and subsampling and fully connected layers. Okay, so all these are part of convolutional neural networks. Okay, and they work very well for images especially, right? But the basic framework of deep learning was a feed forward network only, and that is like a linear, I would say, not a convolutional network. So this is the paper which published in 1998, the first CNN paper. And the reason why CNN was built is that it has fewer connections than a feed forward otherwise. Okay, so essentially convolutional network is basically a optimized filter. Okay, so these are different filters learned in the convolutional network. Okay, so basically these are the papers published in 2012 based on these convolutional filters. So this is known as AluxNet. AluxNet is essentially a convolutional network, right? So the convolutional networks are everywhere. For example, you want to find what is this vehicle on this two passengers are sitting. Okay, so this is known as a motor scooter. So the probability of motor scooter is very high. What is this? This is a leopard. The probability of leopard is very high. What is this? This is a container ship. The probability of container ship is very high. So likewise, convolutional networks can help you identify or classify things with very high probability. Okay. So classification can be done by fully connected layer, and convolutional layer can extract features. Okay. So this is how a convolutional fully connected layer works. So the convolution layer, basically you have an image 32 cross 32 cross 3 image. This is an RGB image. You apply a 5 cross 5 convolution filter. So what will happen is you apply this filter on the volume of image. Okay. So this is a RBG image. You have a filter applied. So this filter would translate and make out a output activation map of this dimension. Okay, so many such activation maps are there. As many number of filters will be there, that many activation maps will be there, right? All right, so then you do subsampling and you extract these different features. Okay, so this is the brief, I would say, a bird's eye view again of convolutional networks. The convolutional networks are, I would say, very in 2000, below 2020, these were very very famous networks. So basically, they will provide, given your input vector, the convolutional layer will give you different sized volumes depending on the size of filter and the zero padding and the stride. Okay. So there are two kinds of strides. So I will, because I'm not really with time here. So I would say that there is something known as a stride. Stride means how much there is a shift in the window on the image across X direction and Y direction. Okay, so depending on stride, there is also one something known as zero padding. So what is zero padding? Essentially that I pad my image with zeros on each side so that I can get a continuous output. Okay, I would say a meaningful output. So this is known as your convolutional spatial convolution module. Okay, if you want to write any code on Python in this torch, PyTorch, you can use this function, spatial convolution. Okay. So this is a PyTorch is a framework where you can write deep learning related code for AI. Okay. So then there is pooling layer. Pooling layer means it does sampling. So it half samples, like this is 1 to 224 cross 224 image. By downsampling, it comes to 120 to 112 cross 112, right? This is how downsampling can be useful. And then there is max pooling, means how you can average or take max of the size of the filter. Okay, so this is 2 cross 2 filter you are applying on this image and with a stride of 2. Okay, so that you can calculate the maximum 2 cross 2 element in this 2 cross 2 matrix. Okay, so you can do subsampling or pooling using max pooling. Okay, so you have, again, this is the way you can calculate the max pooling output using w1 minus f by stride plus 1. Okay, so these are the common settings of max pooling, like you have subsampling by 2 or 3. All right, so these are different kinds of CNN architectures. So you have AlexNet, you have VGGNet, you have GoogleNet, you have ResNet, and nowadays these are the different networks. So AlexNet was the first I would say the second convolutional network, which was implemented by Alex Krzyzewski in his own name. Alex, he has kept it. And VGG is Visual Geometry Group in Oxford University. They came up with this model. GoogleNet is basically a model by Google. So this Google Deep Brain team has come up with the GoogleNet network, which has something known as inception layers. All right, network in network architecture. And there is this ResNet architecture, which is known as a residual network. This has been developed by Microsoft. All right. And so this network in network architecture starting from GoogleNet is also further developed more in the recent times. And you have wide ResNet also and ResNext also. You have DenseNet, FractalNet, SqueezeNet. Okay, these are all some of the recent, I would say, a couple of 4-year-old or 3-year-old architectures. So this is starting from LANet in 1998. There's AlexNet in 2012. You can see the architecture and the number of layers which are increased, and you can see that the size of the convolutional filters has also changed. Okay, and max pooling also. And this is our AlexNet, which has come up in 2012, right? So AlexNet also has a convolutional layer with 11 cross 11 filters applied at a gap of 4 cross 4 filter. Okay, so this is again your AlexNet is working. So this is your AlexNet. You can print the AlexNet architecture as per your choice in PyTorch. Okay, so basically AlexNet is the winner of this challenge, ImageNet Large Scale Visual Recognition Challenge. This is the first CNN based winner in 2000 before 2012. Okay, so there are different further networks which have come up to improve the performance on this ImageNet challenge. So the best so far is a ResNet in 3.57% error. All right, so then here you can see that this is AlexNet. Now this is ZFNet. Okay, ZFNet is just improved hyperparameter optimization on AlexNet. That is the only difference of ZFNet, and that will improve performance by 5%. Okay, then there is an improvement by how much percent? 4%, 4.4%. Okay, and you have increased the number of layers, and then you have increment by 0.6%, and for that you have to increase 3 layers. And Google has done that. Right, but it has of course then comes the ResNet. Okay, and ResNet has almost 152 layers. ResNet has. So as you increase the depth, the performance is becoming better and better. Okay, but to train that is a challenge, of course, which has to be addressed. All right. So this is the memory of architecture. Every architecture you can check here. Once you implement this architecture in your computer, or desktop, or etc., you can always type and check this memory occupied by the program. Right. So for example, here for every image, my program is occupying 96 MB always. Right. So this is VGGNet, as I told you. This is GoogleNet, which is developed by Google. This is Nave Inception module. The GoogleNet is basically a deeper network with sorry, it's gone somewhere. Yeah, GoogleNet is a architecture with this inception connections or bottleneck layers and 1 cross 1 convolution. Okay, so this would help to reduce the depth of features. Okay, so 1 cross 1 convolution is part of GoogleNet or inception network. And then final, the biggest revolution came after Microsoft introduced ResNet. So essentially, what ResNet does is it uses back propagation only, but it is very intelligent in identifying this connection, which is known as a skip connection. So this is also known as a residual connection. So this residual connection helps to train the network in an effective manner. Okay, so it will not block the output to the input. Okay, you can see this. This is the growth of ResNet. So this is a training curve and this is a test curve. Right, the error is becoming smaller and smaller. This is your ResNet with the residual block. Okay, so this is the overall performance. All right, so I will briefly touch another architecture now, which is known as a GAN architecture. Okay, so GAN actually has two layers. One is known as generator, one is known as a discriminator. Okay, so GAN actually does generation and discrimination. So it will help train the generator better. Okay, so basically generator will basically be given as random noise as input, and actual image is expected as output of generator. Okay, and discriminator will identify if the generated data is real or fake. So this is a competition between generator and discriminator, okay, to fool each other. So which will basically give you a good image, or by without fooling each other. Right, so this is application of GAN. Like you see this text to image translation. Given a text, you need an image, right? Image to image translation, like you have a daytime image, you want a nighttime image, or you want to determine the photograph of human faces, right? You give the name of the actress, you give the name of the person, you need this image. Okay, so this is a very important application of GAN. So it can generate different images, okay, with very high fidelity. And the next comes the attention. The attention essentially is focuses on a specific region of the image, which is useful rather than the entire image. Right? This is heat map. So heat map will tell you which region of the image is actually useful for prediction. Okay, you can see this is the image of dog on a cat. So this region of this image is useful. So attention modules are some of the recent works. So you have different attention modules, spatial attention module and channel attention module. Okay, so this convolutional block attention has channel as well as spatial attention module. This was published in very recent paper in 2018. So this attention idea actually came up in this CBAM, convolutional block attention module paper. Okay, so this is a very important module which is very much useful nowadays. What is spatial attention, what is channel attention, and convolutional block attention. So you can integrate attention with convolutional layer. Okay, and then comes something known as a self attention. So basically this is your external attention essentially, but what is known as a self attention. So self attention is, which is a recent technology which has come up in the paper known as transformers. Okay, the transformer architecture is part of ChatGPT, generative pre-trained transformer. It is part of different chatbots. It is part of different natural language in natural language processing automated machines. Okay, so essentially self attention has basically your has introduced these different applications. So I'm saying that self attention essentially is an idea where you have a query, key, and another vector v. So these three, query, key, and value vector, will determine how your attention is focused. Okay, on which embedding your attention must be focused, which region of the image attention must be focused. So what is the query, what is the key, what is the value? So this is your self attention. Self attention means query, key, and value. Depending on that, attention will be adapted. Okay, this is also known as a QKV model. QKV model. So transformers use this QKV model. So transformers will help you predict the output. For example, this is your French. Je suis étudia. This is a French word, French sentence. That means output should be I am a student in English. So that can be done using transformer. Okay, the transformer is like a it can be used as a Google translator. All right. The principle is that it works on self attention module. Then you have vision transformer, like you have this You give a daytime image, you get a nighttime image, right? So you look at this paper, Transformers for Image Recognition, you can get this idea of vision transformer. So these are different transformer-based architectures. One is your BERT, bidirectional encoder representation from transformer. Then there is generative pre-trained transformer, generative pre-trained transformer 2, generative pre-trained transformer 3. Then you have a shifted window transformer, you have vision transformer, right? And then you have DALE, DAL diffusion model, which is upgradation of transformer model, right? All these are very recent technologies. So these are some of the recent technologies I would like to highlight. And finally I would conclude with highlighting some of our works which we do in our lab. So this is a very important application, as I told you at the bottom of the start of the class of the session, that driver drowsiness. Essentially, we can monitor the driver drowsiness phenomena using IoT. Okay, so we work on such application with a EEG based sensor, wearable sensors. And so this is what we have worked in collaboration with Taiwan University, National Xiao Tong University. And we have collected a data set of 27 subjects in their micro sleep setting. And these are some of them are university drivers. Some of these are driving for different administrative officials in Taiwan. And we have published this paper with the idea of deep autoencoders. So this was the best paper award in the recent ICONIP conference. And then this is by head movement analysis, we have done driver drowsiness detection. This basically uses your IoT. As I told you before, this motion sensor you used, right? This part is we have implemented here. So basically, this is the working principle. We have this MPU 6050 sensor, the Arduino module, and we have Bluetooth communication and data processing layer, and finally you have this application layer where we detect the drowsiness. So this is the basic setup of IoT. We have basically this one device only we have here, but I hope that we connect with multiple devices and get a communication possible as soon as possible. And finally, this is a paper which we got published in an Indian International Conference on Pattern Recognition recently at Indian Statistical Institute, Kolkata. So this is where again we worked on this 27 subject driver data, but this time we did using convolutional neural network, using covariance augmented convolutional neural network, right? So in essence, these are some of our publications on this domain. Our main area of focus of thrust is transportation. So basically, we work on different IoT-based transportation approaches and try to enhance the quality of driving for the driver and the corresponding, the passengers. So, and last but not the least, these are also some of the works. We participate regularly in international competitions, and majority of us we have won. Like whatever we participated, at least we had a silver medal. So you can see that this is a competition in 2022 we won with MEG signal processing. So this is the appreciation we had in that competition. And so this is basically you have this neurological disorder monitoring using wearable sensors. Okay. So if you can identify somebody is suffering from dementia or Alzheimer's or mild cognitive impairment using these wearable sensors. Okay, and you can also classify psychosis using this again wearable sensors. It's published in basically his competition was from ICASP Signal Processing Cup competition in 2023, and we have published a paper on this competition essentially in IEEE sensor letters. These are different papers. One is published in IEEE Signal Processing Letters and IEEE Sensor Letters, and this is published in IEEE Sensor Journal. All right. So these are some of our works from our lab. And finally I want to conclude here. This is the last work. So we have image restoration. So essentially, when somebody is driving a car, especially in the North India, maybe I don't know about hilly areas, you have this idea of fog, right? Clouded fogs. So this fogging would essentially disturb the view of the driver. So we need to restore the images in real time for drivers so that they can get a better view of the environment and they can take decisions quickly on the hilly areas or on the go, right? So this is where we proposed the image restoration framework using deep learning. Okay. So here we use the self-attention modules, which all we have taught right now, and transformers, and we have improved the performance of the degraded images. All right. So we had a two-stage restoration architecture. We have amplitude refinement unit and a phase refinement unit. Both of this is done using transformers. This has been published in IEEE CVPR conference, one of the top tier conference in this area of computer vision in 2024. So these are amplitude units and phase refinement units which are built based on transformer architectures. All right. So this is a brief idea of my talk.